So we have two guest talks today. I'm really excited to welcome. I think again, it's been a while since we've had Brad speak at a community meeting or a ROS-I update. But Brad Suessmith is speaking with representing Orbbec today. He's the Robotics Segment Leader with Orbbec, and I thought it was really interesting because there's a real big push, both on their driver side and on the product release side. I thought it'd be great to get them to share kind of what's going on, something that's like can be shared across our community, both obviously here today where we're talking live, but obviously on our YouTube channel, so more people can kind of understand what's up with this. So we're back in all over the place with really great products, and as our developers have noticed, the driver support has been on point. So with that, we wanted to give them a chance to kind of share their story, what's going on, and what the latest updates are. So with us, we have Brad. Brad, the floor is yours. I can stop sharing so you can share.
Okay, hopefully.
See your screen. It looks great.
Okay, awesome. Well, yes, thank you everybody for joining this morning and listening to my presentation. As Matt mentioned, I'm a Robotics Segment Leader, Business Development Manager at Orbbec, and I'm a relatively new employee. I just joined Orbbec in January, as did my manager and another teammate in Europe. Prior to Orbbec, I was with the Intel RealSense sales team for 6.5 years. And I've been attending your meetings for most of that time. So I'm pretty familiar with your organization, and it's a pleasure to be back. And my presentation is composed of primarily just 3 sections, really. For those of you who aren't interested in or familiar with Orbbec, I thought I would give a quick intro to the company and what we're about. And then I'll spend a little bit of time on our product portfolio and our software SDK and ROS support. And then quick summary, and then I'll be happy to answer any questions at the end. I only have about 10 slides of content, so I'll breeze through those pretty quickly. Hopefully we can limit it to 20 minutes, but I'm happy to take calls or questions after the meeting. And I can share these slides as well. This is all public information, so happy to send those out if you'd like. So a little bit about Orbbec. We have 2 regional headquarters. Our North American headquarters are in Troy, Michigan, which is just 30 minutes north of Detroit. Most of our engineering and manufacturing is in Shenzhen, and that's kind of our global headquarters. The company was founded in 2013, so we've been around for 11 years. We have a large number of customers. I realize we haven't been as well known in North America as in Europe as other companies, but that's a big focus for us now, is growing our presence and mind share and market share in those regions. But we've shipped a lot of cameras, over 7 million units so far. Most of those have been in Asia. We have a large number of employees, over 600. That's because we're a vertically integrated company. We build our own cameras, and a lot of smart people with advanced degrees and a lot of patents in our portfolio. We are a publicly traded company on the Shanghai Stock Exchange. We went public in 2022. And we have sales and support people around the world. So no matter where you are, we're happy to work with you to support your designs. So as a recent employee to Orbbec and coming from Intel, I came up with this list of kind of advantages over the last couple of months of where I see we really differentiate, and not just against RealSense, but any other depth camera providers in the industry. So one unique thing about us is that we're exclusively focused on computer vision. That's the only product line we have, so we don't have issues with distractions or competition for resources for other types of products. And we do not compete with our customers, so we don't sell robots or any other end customer products. And on the technology side, we're a little unique in that we're the only provider I'm aware of now that offers all depth cameras utilizing all three of the major technologies. So we have stereo cameras, structured light cameras, and time of flight cameras. Most players in the space focus on one technology. And that's important because, as most of you are probably aware, there's no such thing as a perfect depth technology. Depending upon the lighting conditions, the range to the object, the cost, power, size constraints, different technologies work better than others in different use cases. So the cool thing about Orbbec is we have one common software development kit that works across all of our depth cameras. And so you can mix and match them and move from one to another without having to rewrite all your code. And then a lot of our competitors rely on performing depth processing in software on an expensive and power-hungry GPU. And we're one of the few companies that develops our own custom ASICs. So we develop dedicated ASICs that do the depth processing for our stereo cameras as well as our structured light cameras. And so not only does that save cost, but it saves power as well. And it also makes it easier to move your camera from different CPU host platforms. You're not tied to a particular platform. And then in terms of for stereo cameras specifically, we have kind of a unique approach to our mechanical design of our optics systems. So we isolate the optics from the sensor modules from the PCBs in the camera, and we use a really robust aluminum frame. And using this approach, we found that we haven't had customers come back to us saying, "Oh, I need to recalibrate your camera," or "lost calibration after I dropped it," or "the robot suffered a lot of vibration or shock." So we think that's a real technical benefit for the lifetime of the product. And then, as I mentioned earlier, we're a vertically integrated company. So, we develop our own ASICs, optical designs, PCB designs, industrial designs, mechanical designs, and then we build those cameras in our own factories, which means we don't have to negotiate with a third party to set up a production line and testing and all the delays that are associated with that. And so we can move a lot faster than most companies, and we're more flexible than most companies. And we really believe in our quality because we control that ourselves directly. And so we offer a 3-year warranty on our products. Most of the other players in this industry offer, 1 year or less. And ultimately, that vertical integration also provides a lower cost structure. So we think we offer really high value products at attractive price points. So, with most depth camera companies, we do address a wide variety of markets. For this audience, of course, I'm going to focus more on the robotic arm segment. And we've put in photos here of a few of the top use cases. So bin picking, of course, is a very popular application. Palletization and depalletization. Whoops, I have a typo there. I need to fix that. Too small of print. And then, as you discussed earlier in this meeting, welding, sanding, applications, and assembly. And then we're seeing more interest now from some of the cobot OEMs in terms of combining or coupling vision solutions with their arms, which is kind of new to me because in the past, everybody relied on system integrators to do that work for them. But now looks like some of them are wanting to move up the value chain or the stack and offer that as a solution directly. And then quality control and inspection of items as they're being processed or manufactured is another one. And there's more. These are just some of the ones that we listed here. So a little more detail on some of these in terms of use cases and what the depth camera gets used for. So if you're doing object picking in an unstructured environment, the depth camera is very helpful for identifying and segmenting the object from the other objects surrounding it within the tote or bin or pallet or wherever the item's being picked from. And then it also assists the robot in figuring out where to, excuse me, sorry, I got interrupted from Teams. where to grip the item so that you securely pick it up and don't drop it, either with the suction cups or fingers or whatever the end user tool is. And then once you pick the item, then you need to have a place to put it. So, looking for empty spaces in a destination box or pallet for placement of the object that just got picked is important. The depth camera assists with providing that information. And then I'd be preaching to the choir here, but identifying or generating a depth map of the surface that's being welded or sanded or being ground down, which informs the robot where to apply the tool, or the tip of the instrument being utilized there. That's a really helpful application. And then inspecting the operation after it's been done, whether it's an assembly process or a sanding or welding process. You can compare the end result. If it's a manufacturing environment, a lot of times people have a digital twin CAD model of what the object should look like, and then you can use the camera to identify, oh, it's missing a bolt, or it's missing part of the subassembly, or it wasn't assembled correctly. Things like that can be done. And then on a little different note, I've actually worked with some companies that are trying to use depth cameras to allow robotic arms to work in an interference range of placement. So, without the cameras, the arms could collide potentially because they're working so closely together. Perhaps they're working together on a single item, or just trying to pack in more arms into a smaller space. And by using the cameras, they can identify the motion of the arm and direction of the arm, and slow the arms down or pause them and enable them to work closely together without hitting each other. And then the last one is a new area that I put in red because we don't offer cameras capable of this today. It's something we're investigating, but a number of companies in the industry are looking at using cameras to create a dynamic safety shield around an industrial arm, allowing humans to work closely with their arm without having a cage or traditional light curtains around the arm. And the benefit here would be that the arm could continue operating as long as the human is not in close proximity to where it's operating, instead of just having a static cage around it that blocks off that entire space, regardless of whether the robot's moving or where it is in its range of motion. The cameras could inform the robot to slow its speed or motion, and then stop if the human gets close enough to where it's actually operating in the three-dimensional space. So people view this as a way to maximize utilization of their floor space and also improve overall efficiency of their operations. So in terms of our products, as I mentioned, we have three major technologies. We've got a family of stereo cameras. At Automate, we launched our latest generation, which we're calling the Gemini 330 series. These are built around a new depth processing ASIC that does not only active stereo operation, but also passive stereo. In the past, our cameras were active only, but we've now added the passive stereo capability, which enables them to work without a projector and enables them to work in bright sunlight, because we don't have to worry about the sunlight's infrared energy drowning out the projector dots. They still include a projector for operation in the dark or on surfaces that lack texture, but they can operate in both modes. And we have two different versions, kind of a short range camera, the 335 and the 336, and then a longer range version, the 335L and 336L. If you're familiar with the RealSense products, these are essentially drop-in replacements. They're the same size and fields of view and fundamental capabilities. We have some additional features that RealSense doesn't have, and we have some objective data showing that our depth quality is actually better than theirs. But yeah, if you're familiar with the RealSense family, these are pretty similar. And the difference between the 335 and the 336 is that the 335 does not have any kind of filter over the depth sensors. You can see the depth sensors through the cover glass of the camera here. The 336s add a near-infrared pass filter, which blocks the visible light from entering the sensors. And that's useful primarily in indoor environments where you have shiny or reflective surfaces. Basically, the purpose is to minimize any glare that could enter the sensors and create holes in the depth map. So we give you both options there. And then our time of flight camera family, probably some of you are aware that Microsoft end of life their Connect Azure Connect DK time of flight kit. Unfortunately, this is, I think, the third time Microsoft's exited the depth camera business, but we've licensed that technology from them, and we are actually utilizing the same design and suppliers that they were utilizing. So we have a kind of a direct replacement for the traditional Azure DK USB camera, and we call that family the Femto family. And Femto Bolt is the USB entrance there. So if you're an existing Microsoft Azure Connect DK user, this is kind of not a drop-in replacement. The form factor is a little smaller and a little different, but it's the same functionality. The only thing we removed was the microphone array because we didn't see a lot of demand for that. And then we've come up with two new additions to the family. One is called Femto Mega, which adds a Jetson Nano SoC to perform the depth processing in the camera. In the traditional Microsoft design, the depth processing was actually performed on the host computer. So in this case, we've offloaded that functionality into the camera. And then critically for a lot of customers, we've also added a PoE interface. So you're not restricted to USB. And then Femto Mega I is basically the same camera, but in an industrial IP65 graded enclosure with M.12 connectors for the Ethernet and discrete DC power and synchronization signal interfaces. And then our structured light family is called Astra, and we have two products there. Our latest and greatest product is called Astra 2, and it's a very high resolution camera, operates up to 1600 by 1200 resolution and up to 8 meters distance, so it's pretty long range as well for structured light. And then we've got a very low cost, tiny little camera, Astra Mini Pro, that's VGA resolution. It's more suitable for short range applications that don't need a lot of a lot of pixels, so to speak. Okay, and then I tried to put in some notes in here about where these cameras are useful and what types of applications. So the time of flight cameras, I see these used a lot now in palletization and depalletization functions, primarily because those applications tend to use large industrial arms. So the cameras have to be mounted, typically mounted from the ceiling or quite a distance away from the pallet to enable the arm to have its space to operate in. And so that's a good application for these cameras because with time of flight, you have basically a constant error rate regardless of the distance to the object, unlike stereo where the error rate increases with distance. And time of flight also gives you very good edge definition. So either the photons hit the object and come back to the camera, or they continue on farther. And so that gives you good edge definition around boxes and items that would be placed on pallets. And also, typically, those applications operate in controlled lighting conditions. You don't have to worry about sunlight and operating outdoors generally. And, we have the Ethernet interfaces, so you can get, a long cable run up to the camera in the ceiling. Now, stereo cameras are really good at, short to medium range distances. They're relatively inexpensive. So these get used a lot more in, I'd say, the tote and bin picking types of functions. The other benefit of them is that because they don't rely on a coded light beam, they can interoperate together, so you can have multiple cameras sharing a field of view without interference. And they also deal well with objects that are moving and moving even at really high speed. So maybe analyzing conveyor belts, items on a conveyor belt or something like that, they're good at. And then structured light's really accurate at short to medium distance. So if you need exact distances compared to the ground truth measurement. Structure light's really good for that. Again, they suffer from, if objects are moving, that's not a strength of theirs. And they're also susceptible to sunlight interference. So again, they're more of an indoor type of camera. And yeah, defect detection is a good use case for those. So in terms of software, as Matt was talking about, we do have an open source SDK that we update on a regular basis. I provide the link to its location on GitHub. And again, it supports all of our different cameras. It's cross-platform, so any OS that you would need to use, we support. And then in terms of wrappers, we have both ROS-I and ROS-II support. I've listed the most recent versions that we support, kinetic, melodic, and noetic for ROS-I, and the link here. And then ROS-II, today we've only posted on GitHub so far support for Foxy, Galactic, and Humble. I checked with our marketing team this morning. They said they're in a process of testing Irwini and Jalisco. Apparently Jalisco, there were some major changes made, so it may take a little while to get that one out, but we are working on it. And if any of you have input or concerns or bugs or any issues you find with our ROS support, please let me know, and I'll make sure it gets escalated and addressed. And then we also have wrappers for Unity and Python. And then the Microsoft wrapper here is actually for the Femto camera. For people who were Azure ConnectDK customers and you've already utilized their APIs, you've got this code base, you can use this wrapper to convert that code, so to speak, to the Orbbec SDK. So you wouldn't have to rewrite your API calls. You could keep your code as it is and build with this wrapper and have a working solution pretty quickly. Just a quick screenshot of our viewer. This is pretty typical. We offer a viewer that allows you to get up and running and test the camera in a couple minutes. They'll show you the depth maps, the point clouds, and RGB image and the IMU data. And then you can perform all the configuration and start and stop streams and things like that, and set up filters on the left side. Pretty easy to use. And then we also, besides selling depth cameras, we also offer ODM and CM services. So we do everything from consulting to concept creation to a whole product design, and we can even do design for manufacturing and build the products in our factories and manage supply chain for you. So if you come across applications where you're lacking the resources or perhaps the knowledge, particularly if it involves computer vision, we have particular expertise there that we can apply. So just to summarize, we're trying to make a commitment to making development for robotics customers easier through the wide variety of cameras we have that can support most of the use cases in the market. We've got easy to use USB and Ethernet interfaces, cross-platform SDK, good ROS support, as we talked about. We've also done a lot of work to integrate with the NVIDIA Jetson ecosystem. We're CPU independent. We work with Intel platforms, AMD platforms, Qualcomm Snapdragon, NXP, i.M, X8, Raspberry Pi. You can use whatever you want. But NVIDIA, is kind of the 800-pound gorilla in the robotics space now, and they're developing more and more reference platforms and software stacks themselves. And so we're working really hard now to integrate with that. We recently announced integration with their NV blocks and their vSLAM code base, and then just a couple weeks ago with their Perceptor software architecture as well. And I just mentioned our ODM and CM services, and we have local sales and support. So here's our website URL. And if anybody has any questions, feel free to send me an email or give me a call. I'd be happy to chat with you further.
Sorry,
I have a quick question.
we have a question from the audience. Go for it.
Thank you very much for your presentation. Maybe I missed it, but can you like give some few points why your product is better than RealSense? What is your main advantages over what Intel provide?
This might get a little technical, but one of the things we done is our dot projector has is far more dots than the RealSense equivalent. So we put out over 20,000 dots on the scene, whereas RealSense has publicly stated in their white papers that their projector only emits 6,000 dots. And that helps us get much better edge definition in the field of view, you know, and this would be while operating in the active type of stereo mode. Obviously, if you're in passive mode, you're extracting texture from the scene. So it depends on how much texture is in the scene. But that is one area of improvement. Another thing we did, which I talked about earlier in the presentation, was the way we design our optical frame is much more robust than the RealSense stainless steel box, I would call it. And you can tell if you pick up our camera and pick up the equivalent RealSense camera, it's a much heavier design. And that maintains the calibration stability of the camera through thermal variations and shock and vibration. And for stereo cameras, having that tight calibration is really critical. And then another thing we do that's a little unique is that we make the IMU a standard feature. So there's no like D435 and D435i. All of our cameras have an IMU. And then we also include a proximity sensor. So stereo cameras have this issue where if an object's so close to the camera within this min-Z zone, the camera can't compute any depth data for that object. And that's true for our cameras as well. But we also offer the proximity sensor that gives you a distance value. It's only a single pixel, but it gives you that distance value for objects within that min-Z. So that's another benefit. And we've got some data we can share with you under NDA that shows our precision and accuracy variation in comparison to competitors, which we'd be happy to discuss. But we're also
oh, sorry, not to interrupt, Brad, but Amit shared the blog post by OpenCV.
Oh, okay. Thanks, Amit. And then lastly, I'd say we're on our 3rd generation stereo processing ASIC. So we've been making improvements over 3 generations. And you know, the RealSense D4 ASIC has been around since 2017. So it's a older design, I would say. So we've incorporated our learnings into our latest chips.
Thank
you very much.
Yeah, the OpenCV article's got some nice side-by-side data.
Yeah, and that's from
thanks for taking the time and just to drive awareness, right? Like, you know, like I said, like we've been poking around the Astra, and then it kind of like sort of disappeared or support kind of waned, so we pivoted back, and it's just nice to know what's out there, particularly where there's, you know, you could post an issue and actually someone responds. So that's why I thought it'd be prudent to have you come to the community meeting, and I appreciate you taking the time. Thanks, Brent.
Oh, you're welcome. Thank you, Matt. Thank you, everybody, for your time and attention.